All right, guys, last video for our unit, video number 8, word problems. All right, here we go. Here we go. Okay, so we're going to do 2 examples of some word problems just to show you guys kind of how they work a little bit. All right, so our first one says the population P in thousands of Austin, Texas is given by this equation. P equals 241 e to the power of k times t, where t equals 0 represents the year 2010. In 2000, the population was 175,000. Find the value of k for this problem. All right, so here we go. So the first thing we're going to do is we are going to use kind of the information we're given. So looking at the equation, all right, which is that P equals 241 EKT. All right, we know P is the population after however much time, and K we don't know. E is just the number roughly 2.72, so that's not a variable, it's a number. All right, so we're just going to kind of plug in some stuff we know. So we know that the population 175. All right, and remember it also says this is in thousands. So when we plug in 175,000, we really only are plugging in 175. So we've got 175 equals 241e. Now we don't know k, but for this problem we do know time. All right, so it says t equals 0 represents the year 2010. All right, so in 2000, that would be 10 years previous to 2010. So we know that time for this problem for 175 would be negative 10 years previous. All right, so a negative 10 for our t. All right, so let's go ahead now, and we only have one variable left. We just have k to solve for, so we can do it. So divide by 241. All right, so 175, 241, so we get 0.726 equals e to the negative 10k. All right, so at this point, we're trying to get our variable by itself. We need to get it out of the exponent. We're going to apply the inverse property. So for base of e, the inverse of that is log base e, which is natural log. So we're going to take the natural log of both sides. All right, so we have ln of 0.726 equaling negative 10k, and then just divide both sides by negative 10. So k is the natural log of that number divided by negative 10. All right, so we get a 0.032 value for k. So find the value of k. K is 0.032. All right, so the next part says, what would the population be in the year 2025? So we have our general equation now. So we know that our equation is 241 e to the 0.032 t. All right, so that's our general equation because we now know what k is. All right, the year 2025. All right, so our equation represents the year 2010. So we just want to do 2025 subtract 2010. That's a difference of 15 years. So we're looking for what is it when t is 15. So y equals 241 e 0.032 times 15. 241 e to the power of 0.032 times 15, enter. All right, and then we get 389.474. All right, and remember this is in thousands, so if we actually want to know how many people we have, this we're just going to move our decimal. So it's 389,474 roughly. All right, so there's our first example. All right, so that's just using an equation that they gave you. All right, the next one, we're also using an equation that they give us, but there's a lot more to this equation than the last one, and we have to find more pieces. Okay, so the first part of the problem is just explaining to us what the equation means because there's nothing that's given to us in this problem. So the equation T equals AE to the KT plus C is called Newton's law of cooling and can be used to calculate the temperature T of a cooling object, where K is the cooling constant, T is the time elapsed, C is the room temperature, and the constant A is related to but not necessarily the starting temperature. Okay, so all of that was just trying to explain to us what this formula is. All right, so here's the actual problem. It says a cup of coffee is made with water poured at exactly 208 degrees Fahrenheit at exactly 12:30 p.m. and placed on the counter of a cafe whose temperature is set at a constant 72 degrees Fahrenheit. Okay, we can unpack some of this information. Okay, so 208. All right, this is when time is 0, our temperature is 208 degrees Fahrenheit. All right, so our water is poured and it's exactly 208. So when time is 0, our temperature, capital T, is 208. Okay, cool. Then it says it's placed on the counter of a cafe whose temperature is set at a constant 72 degrees. So this constant 72 degrees. This is our room temperature. All right, and we know what this is in the problem. This is our C, right? So C in our equation is our room temperature. So we know that for our problem, C is 72. All right, then it says after 5 minutes, the temperature of the coffee is 192 degrees Fahrenheit. All right, so this is giving us more information. All right, so 5 minutes, we're at 192. So this is telling us when T equals 5, capital T is 192 degrees. Okay, find the constants A and K, and then find the time you can begin to drink your coffee if you want its temperature to be 175 degrees. Okay, so there's a lot of stuff that we need to start unpacking. So let's just start by plugging what we know in. So here's our equation. T equals A e to the KT plus C. All right, now we know that E is just a constant. It's a number, so that's going to stay. All right. We also know what C is. Okay, C is 72. That's our room temperature. All right. Now, we know we're going to have to solve for both A and K and to make our general equation because T, big T, little t are our variables for our problem. Those are the things that are going to change. Those are like our X and our Y's. All right. Now, let's try and see if we can find A first. All right, the reason we want to find A first is because we have enough information to kind of know what A is from the beginning. So they gave us when T is 0, capital T is 208. All right, so what I'm going to do is I'm going to plug that information in. All right, so I don't know what A is, but capital T, temperature, is 208 when little t is 0. All right, now the reason this is going to be nice is because we don't have to know what K is because K times 0 is just 0. All right, so what we now have is 208 equals A e to the 0 plus 72. Well, what is anything to the power of 0? Anything to the power of 0 is just 1. So this is now a nice simple 208 equals A plus 72. We can just subtract 208 subtract 72 and we get 136 as our A value. All right, so that's our first step. So we now know that A is 136. All right, now we can rewrite our equation because we now know more. All right, so now we have T equals 136 e to the KT plus 72. All right, the next thing that we need to find is our K value, and they did give us some information to use to find that. All right, so now we've got this, T equals 5, capital T is 192. All right, so we can go ahead and we can plug that in, and once we do that, we should then only have one variable left, which is K, and then we can solve for that. All right, so 192 equals 136, e to the 5 minutes, so 5k plus 72. All right, so if we go ahead and solve this, we have 192 subtract 72, divide by 136. All right, we get 0.8824 equals e to the 5k. All right, so all I do is subtract 72 and then divide by 136. All right, and so that's the number that I got. Our next step is going to be to get the 5k out of our exponent. So we're doing our inverse operations. We're going to take the natural log of both sides. So we have natural log of 0.8824 equaling 5k, and then we can just divide both sides by 5. So in my calculator, I'm just typing that in, and I got negative 0.025 equals my k value. So now we have a k. So we now have our a value, we have our k value, and we have now at this point a full equation for our problem. All right, so here we go. Last time we need to kind of write this until we can kind of just solve the rest of the problem. So we have t equals 136 e to the negative 0.025t plus 72. Now our only variables left in our problem are big T for our overall temperature after little t time. All right, so there's our finished equation. Now we can use that to answer the final question. Find the time you can begin to drink your coffee if you want its temperature to be 175 degrees. All right, so 175 is the optimal temperature to drink your coffee at. Fun fact. All right, so this is a capital T value. We want to find the little t value, how much time has gone by. All right, so we're going to plug in 175 for our capital T. All right. So again, we're going to kind of do most of this in our calculator. All right, so we've got 175. We're going to subtract 72. We're going to divide by 136. And now we have 0.7574 equals e to the negative 0.025t. All right, we're going to go ahead and apply our inverse property. So we're going to take the natural log of both sides. So we've got natural log of 0.7574 equaling negative 0.025t, and then divide both sides by negative 0.025. So natural log of that answer divided by negative 0.025. Enter, and we get t equals 11.12 minutes. And there's our answer. All right, so that one was a little bit more involved than the first one. We kind of actually used similar equations, right? They were both like something e to the kt. This one just had a constant room temperature that was kind of playing into effect, but they did work pretty similar. We just had to find, really it was the finding of the a that was different. The top equation, right, didn't have an a value that we had to look for, right? So it was that, but there was no plus c, and so our a value was just our starting value, whereas before we had to take into account that room temperature starting bit, which made it a little bit challenging because finding the a at the very beginning. But that is what your log kind of equations look like. All right, just make sure you kind of identify your variables to begin with. Like, do you understand what all of the parts in your equation are? And then from there, it's just kind of isolating and plugging in and solving for whatever variable you're looking for in the moment. All right, there's a lot of different types of equations you guys are going to see. If it's an equation that is different from like what you normally work with, you'll be given the equation. If it's not just like a standard exponential scenario. But yeah, so hopefully that was helpful, and you guys are now able to work through homework number 8. So that's our last one, and that's our last video. Hopefully these were helpful. I hope the second round of videos was a little bit nicer. It looks like you guys should be able to see more of the screen as I'm kind of working through the problem, but if you have any questions, please feel free to reach out. And yeah, hope that was good. Hope that was a good review for exponentials and logs. But yeah, all right, bye guys. Stop recording.